Have you ever had one of those moments where you just wished you could rewind the clock, fix a mistake, or maybe jump ahead, just to see how things turn out? Well, today we're tackling one of the biggest, most mind-bending ideas out there, time travel. Let's find out if it's more than just a sci-fi dream. And you really can't start this conversation without a little wisdom from the guy who basically broke our concept of time, Albert Einstein. His theories of relativity just completely flipped the script. They showed us that time isn't this constant, unchangeable river flowing in one direction. Nope, it's more like a fabric that can be bent, stretched, and warped. And that one single idea, well, it opens the door for everything we're about to talk about. So before we dive headfirst into the heavy physics, let's talk about where most of us even got the idea, right? Science fiction. For more than 100 years, we've been obsessed with stories that ask that amazing question. What if? What if you could actually go back and change your own story? I mean, think about it. From H.G. Wells's groundbreaking novel, to Doctor Who's iconic blue box, to that DeLorean hitting 88 miles per hour, these stories have literally shaped our imagination. They've given us this classic picture of hopping into some wild machine to visit the past or the future. But they also get us thinking about the huge, messy consequences of doing that. Okay, but what if I told you time travel isn't just for the movies? What if I told you that in a very real, very scientifically proven way, you are a time traveler, and you're doing it right now? So for a physicist, time travel isn't about flashing lights and special effects. It's much simpler and honestly much weirder. It all boils down to a mismatch. It happens when the time you've experienced on your watch doesn't equal the time that has passed for everyone and everything else. And that leads us to this really simple but kind of profound truth. We are all moving into the future. Every single second that ticks by is another step forward in time. It's the most basic kind of time travel, but hey, we're all doing it all the time. And this isn't just some philosophical idea. It has huge real-world consequences. Take GPS. The satellites orbiting way up above us are moving so fast, their clocks actually run faster than ours down here on the ground. We're talking 38 microseconds every single day. Now that sounds tiny, right? But if engineers didn't correct for that little bit of time travel, your GPS would be off by miles in less than a day. So let's get into the nitty-gritty of this proven kind of time travel. Because while we can't seem to rewind the clock, the laws of physics are totally cool with us fast-forwarding. And the magic ingredient here is something called time dilation. This is where things get really, really weird and awesome. It's a key part of relativity, and it says the faster you move through space, the slower you move through time, at least compared to someone standing still. And the same thing happens when you get near something really massive. Its gravity literally slows time down. So, you want to take a one-way trip to the future? Well, physics gives us two potential recipes. First, you could build a ridiculously fast spaceship and travel near the speed of light. When you came back to Earth, years or even centuries could have passed, while you'd only have aged a little. Option 2? Get heavy. Park yourself in orbit around a supermassive object, like a black hole. Its insane gravity would slow your time down so much that the rest of the universe would just race ahead. Okay, so traveling to the future? It's on the table. But what about the holy grail of time travel, going backwards? This is where we step away from proven science and walk right into the mind-bending world of pure theory. And this chart really lays it all out. Getting to the future is a direct result of Einstein's theories. We know it works. But traveling to the past? That is a whole different ballgame. It would mean we'd have to find a way to literally warp and twist the fabric of space-time itself, using physics we're not even sure exists. Probably the most famous idea for going back in time is the wormhole. A hypothetical tunnel through space-time. Imagine it like a shortcut connecting two different points in time. If we could actually build one of these things and keep it stable, you could theoretically just step through from today into yesterday. And then there is an even crazier idea, a closed time-like curve. The best way to think about it is like a cosmic racetrack for time. If you could find a path through the universe that literally loops back on itself, you could follow it all the way around and end up right back in the moment you started. But, okay, let's just pretend for a second that these shortcuts are real. Traveling to the past isn't just an engineering problem. It's a massive logic problem. It opens up a huge can of worms called paradoxes, things that could threaten to tear apart the very idea of cause and effect. And this is the one everyone always talks about, the grandfather paradox. What if you went back in time and, got rid of your own grandfather before he met your grandmother? Well, then you would never have been born. But If you were never born, who went back in time to cause all the trouble in the first place? It's a total brain breaker. And that's the core of the problem, isn't it? On one hand, you have free will. You have the ability and the tools to change history. But on the other hand, the past is a fixed fact. Actually changing it would make your own existence completely impossible. It's like an unstoppable force meeting an immovable object. So, how might the universe solve this? Well, one really cool idea suggests you simply can't change the past because you were always a part of it. The universe doesn't need to throw up some cosmic force field to stop you. It just needs ordinary, everyday stuff to happen. Your gun jams. You slip on a banana peel. A bird gets in the way. Or maybe you just have a change of heart. The outcome is the same. The past stays intact. This leads us to another weird scenario, the causal loop or bootstrap paradox. So picture this. A time traveler goes back and gives a young Shakespeare a book containing all his future plays. Shakespeare just copies them out and becomes the most famous playwright of all time. Centuries later, that same book makes its way into the hands of the time traveler, who then takes it back to Shakespeare. So the question is, who actually wrote the plays? They seem to have no origin at all. So after all this talk about wormholes and paradoxes and twisting space-time, we're left with one really, really simple question. The late, great Stephen Hawking put it just perfectly. His logic was simple but pretty hard to argue with. If traveling to the past were ever possible at any point in the future, wouldn't someone have come back by now? Shouldn't our history books be filled with sightings of tourists from the future? The fact that they're not, that silence, is pretty powerful evidence. And that's where we're going to leave it. While physics doesn't slam the door completely shut on going back in time, the logical hurdles are just immense. So for now, I guess we'll just have to be happy with our one-way trip into the future, moving forward 1 second at a time. But who knows? Something to think about, isn't it?